So, Assalamu alaikum and good day, class. So, this is obviously our lecture on bearing stress and thin wall pressure vessels. Okay. Before I start this discussion, I want to give you the program or mechanics for this video. So I have come up with my mind that I will be dividing this lecture into 4 videos. Okay. Take note, 4 videos dapat itong lecture na ito. First video is actually a concept behind bearing stress at saka summary at saka recall or recap ng previous discussion. Okay? Second video is actually examples of bearing stress. Again, examples of bearing stress. Third video is about concept behind thin-walled pressure vessels. And fourth video is more likely to be an example or examples of thin-walled pressure vessels. Okay? So, yun nga. I want to give you the emphasis na in this subject, with the strength of materials, previous discussion or previous lectures are actually important all throughout this subject. Hindi lang sa subject na ito, but in your future majors, okay, in your higher majors. Because strength of materials is actually a very, very critical subject for your higher majors, okay? So I want you to pay attention for this subject. So that's the bottom line of what I wanted to tell you. So meaning to say, in this video, I will be talking about concept behind bearing stress, at the same time a recap or a recall of our midterm or prelim coverage, which are normal stress at saka shearing stress. Okay, so let's go back first to normal stress. Okay, so in this lecture we will be talking about normal stress first. So what exactly is a normal stress? Normal stress is actually a type of stress in which the force is actually perpendicular to the cross-sectional area. So, basically, the application of load, or when the load is being applied into a system or sa isang body, yung gina-consider natin na surface is perpendicular to that force. To give you the crystal clear emphasis of normal stress, let's consider this figure. Considering this figure has length A at saka width B. Okay? So tapos, here is our load. The application of load is in here. So force F. As you can see, normal stress is this force is perpendicular to the cross-sectional area. So our cross-sectional area is this one. Gets? So again, the force is perpendicular to the cross-sectional area. So we denote by formula normal stress, which is sigma is equal to force over the perpendicular area. So force over A times B. That is how we should do the analysis for normal stress. Again, force over the perpendicular cross-sectional area, which is A times B. Second, shearing stress. Actually, normal stress at saka shearing stress ay magkapareho lang. Pero the concept behind shearing stress, ang pinagkaiba lang is yung perpendicular. Sa shearing stress, the force is actually parallel to the cross-sectional area. As you can see, sa normal stress, yung force daw is perpendicular to the cross-sectional area. Dito na naman sa shearing stress, the force is parallel to the cross-sectional area. So considering this diagram, let's say it has a length of A and width of B. Yung force natin, yung application ng force is nandito. Okay? So yung cross-sectional area natin, we denote force sa shearing stress as V. So sa shearing stress, yung application ng load is dapat parallel to the cross-sectional area. This is the force. So meaning to say, yung cross-sectional area natin is nandito because it should be parallel to the cross-sectional area. May gets you to? So as you can see, considering this considering this eraser, so sa normal stress, yung force natin is perpendicular to the cross-sectional area. This is the block, tapos ito yung force. As you can see, ito yung application ng force. Tapos, yung sa definition is perpendicular daw sa cross-sectional area. Meaning to say, this is the force and this is the perpendicular area. Okay? So, this is the force and this is the perpendicular area. Next, sa shearing stress, yung nakasaad dito or it is being stated that the force is parallel to the cross-sectional area. So, this is the force and this is the cross-sectional area. So, meaning to say, ito yung application ng load, tapos ito yung force na dapat na i-analyze natin. Okay? So, meaning to say, F is equal to V over A. Or simply, V over A times B. Okay? So, again, this is the force and this is our cross-sectional area. Meaning to say, force is parallel to the cross-sectional area na gina-analyze natin. Gets mo yun? So, next, proceed tayo sa bearing stress. I hope everything is crystal clear. Pero if it happen na may question kayo of, or if it so happen na may hindi kayo maintindihan, just comment down below sa comment section. Okay class, next. Start tayo sa lecture natin ngayon, supposedly, which is the bearing stress. Actually, if we are to differ normal stress to bearing stress, magkapareho lang. Okay? Considering its formula, sigma, same lang yung formula. Pero sa bearing stress, may subscript na B. So, FB over AB. As you can see, sigma is equal to force over area, or bearing stress is equal to bearing force over area bearing. So, as you can see, they are both they both shared the same formula. Pero ano nga ba ang difference ng dalawa? So, yung difference ng dalawa, just refer to your handouts. Yung nakalagay sa bearing stress is the contact pressure between two separate bodies. Again, two separate bodies. That is the key word or key terms for bearing stress. Sa normal stress, isang body lang yung involved. Isang block lang, for example. Isang body lang yung involved. Pero sa bearing stress, duwa din man din na body or duwa din man din na materials. So, yun yung pinagkaiba. For example, itong figure na ito. We have this wood. We have these two blocks. This one and this one. Considering this one has its own thickness. Okay? Thickness T. At tapos ito, may height ito na A. Okay. Are you still following this lecture? Again, considering na this one, biasa ya, dia malaw na thickness na T. Tapos nagyama na nakakuan, nakahiga, may thickness siya na A. Okay? So let's chop this one into let's chop this diagram center. Draw natin ulit. Imagine your figure. Sometimes, sa strength of materials, it has something to do with the analysis or your imagination sa mga materials. Okay? Or sa figures. Yan o. Yan. Example na, niya putol na sa'yo. So yun, di ba? Niya katanwa ya saya. So meaning to say, nandito yung thickness, ito yung thickness, may thickness dito, tapos ito is, may height na A. May gets yun? Kiklalo sa video. As you can see, sa bearing stress, for example, itong figure na ito, may thickness to na T, tapos may thickness itong part na ito na A. Again, sa bearing stress, this is two separate bodies. So, if we are to cut this diagram dito sa center, ito yung magiging itsura, okay? So meaning to say, sabi ko kanina, may thickness ito na T, tapos itong part na ito is may thickness na A. So if you are to analyze, this to what is yung may bearing stress. Ito yung may bearing stress, okay? So imagine FB is over A times T. Okay, so again, sa bearing stress, it has something to do with the application of force into these two separate bodies. And of course, perpendiculars kaya no. For example, nandito yung force. This is yung force. Force F at saka yung force F nandito. Okay? So, hindi pagpinsan. May application of force dito, which is, di ba, this is force. So, as you can see, di ba, yes, of force, tatanin? Di ba, may imagine yung perpendicular of dia force na perpendicular sa dia area saya. So, yan yung analysis in terms of what is this? In terms of bearing stress. Same lang sa normal stress. Again, normal stress yung bearing stress magkapareho. Pero yung pinakaiba lang is, yung sa bearing stress, it involves two separate bodies. Sa normal stress, of course, force is perpendicular to the cross-sectional area. Same goes in here. The force is perpendicular to the cross-sectional area. Ito yung cross-sectional area natin. Wala na ink. Tapos ito yung force. Okay? Ito yung force. So, obviously, same lang sila, pero yung sa bearing stress lang is two separate bodies or two materials. Okay? So, this is all for now for the concept behind bearing stress. So, for our next video is about the examples ng bearing stress. Okay? And take note, class, make sure na while listening or while playing this video is you have with you your handouts, okay? Kung pwede lang paki-print, I highly encourage that you print your handouts. So, this is the end of our first video.